Sine and cosine ratios. So in this section, it's very similar to tangent, except we're going to bring in using sine and cosine. You might have already noticed those two ratios on your calculator. So these deal with using the hypotenuse. Notice tangent, we only used adjacent and opposite. Sine and cosine are both going to use hypotenuse. So it's still important to know the parts of the triangle. So notice the diagram at the top of our notes. It's still the same. We're still incorporating alpha and beta. C is still going to be the hypotenuse. That's still going to be your longest side of the triangle. Your two angles have to add up to be 90 degrees. We're still going to use Pythagorean theorem if necessary. A squared plus b squared equals c squared. Now, you might have noticed, you might have already read our funny little saying that we have up here. Some old hippie caught another hippie tripping on acid. This is a way to remember our trig ratios, okay? So the way that we use this is we've got our S, our O, and our H, C, A, H, T, O, A. And the way that we use this is some old hippie caught another hippie tripping on acid. And that's how you remember your trig ratios. Because as we do this, and I'm going to highlight these as I read them off, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. There's two other ways to remember this as well, but this saying is by far my favorite because I think it's the funniest. But another way to remember it, if you can remember the order sine, cosine, tangent, because that's the order that it's in on your calculator, is, oh heck, another hour of algebra. And then another way that some people think of it is they think of it as this. They just write it out like that, and they just think it is SOHCAHTOA. And it kind of sounds like a Indian word. So SOHCAHTOA. But I just like the saying, some old hippie caught another hippie tripping on acid. Okay, so let's get into this. And for the first one, let's find the sine ratio of each triangle in relation to alpha and beta. So for our first one, if we do sine, and we abbreviate it by basically leaving off the E. And it is sine. We don't say it's sin. There is no sinning in math class. So you always say this sine. So the sine of alpha, so remember we're going to start with alpha. Alpha is opposite over hypotenuse. So opposite is 4. The hypotenuse is 5. Then if we do cosine, oh, sorry, not cosine. I meant to do beta. I'm getting ahead of myself. Sine of beta, opposite is going to be 3 over 5. So all of these are all going to be over the hypotenuse. And you will never have on these an improper fraction. Okay, so the biggest number for sine and cosine, your biggest number in your fraction should always be on the bottom. So for sine and cosine, once again, for sine and cosine, your biggest number should always be on the bottom. So for B, your sine of alpha, opposite is going to be 6. Hypotenuse is 10, and it may help for you to go ahead and label hypotenuse first so you know which number is always going to be on the bottom. Then your sine of beta, so go opposite, is going to be 8 over 10. All right, for C, here's your hypotenuse. So sine of alpha, if you go opposite, is 9, so 9 over 15. And then sine of beta, if you go opposite of beta, is 12 over 15. And for D, sine of alpha, okay, so here's our hypotenuse. Hypotenuse is 8. Sine of alpha is going to be 7 over 8. Sine of beta, if you go opposite from beta, is going to be 4 over 8. And you can leave it just like that. You don't have to worry about reducing. Okay, now let's go to cosine. Okay, cosine is adjacent over hypotenuse. So here's my hypotenuse. So cosine of alpha is adjacent. Remember, adjacent means beside of. So it's going to be 3 over 5. Cosine of beta, so adjacent here, is going to be 4 over 5. Once again, your biggest number will always be on the bottom. All right, here's my hypotenuse. Cosine of alpha, the 8 is right beside of it. It's the closest to it. So adjacent, beside of, the closest one to it. 6 is opposite. It's the furthest away. So 8 over 10. Cosine of beta, so the 6 is close to the beta, so it's going to be 6 over 10. All right, for C, cosine of alpha. Okay, so here's my hypotenuse. Cosine of alpha, the 12 is the closest to it, so 12 over 15. And let's do beta. We'll stick it up here. Cosine of beta is 9 over 15. All right, then on D, cosine of alpha. So here's my hypotenuse. The 8 is your hypotenuse because it's the biggest side. Cosine of alpha is going to be 4 over 8. Cosine of beta is going to be 7 over 8. Okay. Now, so just like our inverse tangent, remember this is inverse. It's not tangent to the negative first power. We call that inverse. That can be used to find the angle measure. We can also use inverse sine and inverse cosine on our calculator as well. And remember, to get those, you hit the second button. So you'll either hit second sine or you'll hit second cosine to get the angle, and then you'll type in the fraction. Okay, so if we find the measure of each angle on these problems. So on these, what we have to do, I'm not telling you to which to use. I'm not telling you to use sine or cosine. We have to figure that out based on whether the number is opposite or adjacent to alpha or beta. Okay, so we have to figure that out. So for alpha, going across alpha here, is 12 opposite alpha or is it adjacent to alpha? Well, it's opposite because it's going across the triangle. It's far away from it. So we've got opposite and we've got hypotenuse. This is opposite. So which trig function uses opposite and hypotenuse? Which one uses that combination? Well, that would be sine. So sine of alpha is opposite and hypotenuse, so that would be 12 over 20. So we'll do inverse sine, 12 over 20. Okay, so let's see here. We'll clear that out. And remember, like yesterday, you need to make sure your mode is in degree mode. Always make sure your mode is in degree. So you just hit the mode button. You go check 3 rows down. You see that where it says radian degree, make sure degree is highlighted. And hit second mode to get back out to your main screen. So I would hit second sine, because I'm using sine, and I would do 12 over 20. And I would get 36.87 degrees. So 36.87 degrees. Okay. Now on this one, for beta, okay, so this is my hypotenuse, The 4 is adjacent to it. It's right beside of it. It's not across the triangle. It's not far away. It's right beside of it. So therefore, I'm using cosine. Cosine of beta adjacent 4 over 6. Remember, the 6 has to go on the bottom. For sine and cosine, your bigger number has to go on the bottom. So I'll do inverse cosine 4 over 6. So second cosine 4 over 6, 48.19. So 48.19 degrees. Okay, on C. So here's my hypotenuse. 15 is the hypotenuse. Actually, this one is a typo. I need to fix this one. This one's a typo. So we need to adjust this one. This should be 18. Pretend this is 15. So pretend that's originally on your paper there. Okay. So here is our hypotenuse. The 18 is your hypotenuse because the hypotenuse is supposed to be your longest side, and it's opposite from your right angle. And is 15 opposite from alpha, or is it adjacent? Well, it is adjacent because it's right beside of it. Remember, this would be opposite because it's going across the triangle, which means 15 is adjacent. Therefore, we are using cosine because cosine is adjacent and opposite. So cosine of alpha is 15 over 18. So we will do inverse cosine. So second cosine, 15 over 18. And that will give us 33.56. So 33.56 degrees. And then our last one here. Here's our hypotenuse. Okay, once again, we got to figure out, is 6 opposite from beta or is it adjacent? And it's right there beside of it. So we're using cosine again. Cosine of beta equals 6 over 10. So we'll do inverse cosine 6 over 10. So second cosine 6 over 10. So remember, anytime you're looking for an angle, you use you hit the second button. So 53.13. Okay? So 53.13 degrees. Okay. So now let's look for sides of a triangle. Okay, so very similar to what we did with tangent. The only difference is we're deciding between sine and cosine. That is the only difference. Okay? So this is our hypotenuse. Once again, we decide, is this adjacent or is it opposite? And it is adjacent. So we're using cosine 43. Adjacent is 20. And the hypotenuse is x. That's what we don't know. So just like we did yesterday, when x is on the bottom, these two switch places. Okay, so we have x equals 20 divided by cosine of 43. Okay, now since we're looking for a side, we do not hit the second button. Remember that little phrase we wrote on our notes? Seconds, sides don't get seconds. Sides don't get seconds. So I just type in 20 divided by cosine of 43. 20 divided by cosine of 43. Type it in just like that. And we get 27.35. Okay. So x equals 27.35. Okay. So for our next one, here's my hypotenuse. Okay, here's 56. We're going across the triangle this time. So that means this is opposite. So opposite and hypotenuse means I'm using sine. So sine of 56, remember your angle goes immediately after whatever trig word you're writing and whatever trig function you're writing, equals 4 over x. So since x is on the bottom, they got to switch places. So we get x equals 4 over sine of 56. So I'm going to do 4 divided by sine of 56. 4 divided by sine of 56 and I get 4.82. So x equals 4.82. Okay, so on this one, here's my hypotenuse. This is going all the way across the triangle, meaning that's my opposite. So opposite is sine. So sine of 65 equals x over 18. Opposite over hypotenuse. Opposite goes on top, the bigger number goes on top. So since 18 is on the bottom this time, I just move it up and over. And all I got to do this time is 18 times sine of 65. So 18 times sine of 65. And notice I didn't even have to multiply. I didn't even have to hit the multiplication key. I can just hit 18 sine 65. And that gives me 16.31. So 16.31 is my x. Okay, so here 8 is my hypotenuse, and then x is adjacent because it's right there close to the 38. I know it's close to it, so it's adjacent. So therefore, I'm using cosine. Cosine uses adjacent. Cosine of 38 is x over 8 because hypotenuse always goes on the bottom. Okay, so 8 goes up and over, so I'm multiplying. Okay, so 8 times cosine of 38, 6.30. Okay. All right, so if you feel like you're getting the hang of it, now would be a good time to pause and maybe try these 4 on your own, or kind of pause and look at one and try one and then play it. Okay, so for E, here's your hypotenuse. This is going across the triangle, which means this is opposite. So we are using sine. Sine of 53 equals 20 over x. So we would switch places. If x is on the bottom, you switch with these two. So x equals 20 over sine of 53. So 20 divided by sine of 53, and we'll get 25.04. So x equals 25.04. Okay, so on this one, here's hypotenuse. The 46 and 23 are very close together, which means it is adjacent. So we are using cosine. Cosine of 46, so that's 23 over x. Hypotenuse is always on the bottom. These have to switch places. So we will get x equals 23 over cosine of 46. So 23 divided by cosine of 46. 23 divided by cosine of 46. And we'll get 33.11. So x equals 33.11. All right, on this one, 25 is my hypotenuse because it's across from the right angle. These two are really close together, which means that's adjacent. So I'm using cosine. Cosine of 62 is going to be x over 25. 25, I just move it up and over, and I multiply. 25 times cosine of 62. 25 times cosine of 62. And that gives me 11.74. 11.74. Okay, last one like this. 15 is my hypotenuse. These are really close together, so that is adjacent, which means I'm using cosine. So cosine of 48 equals x over 15. I move 15 up and over. So I'm multiplying 15 times cosine of 48. And that gives me 10.04. Okay, now, if you are having trouble picking out whether to use sine or cosine, and I'm going to put a link, I've got a link down below here that you can click on. You can go to this website here. And what it does is it gives you a picture here of what hypotenuse, your longest side, and kind of in relation. So you can see theta here and gives you opposite and adjacent. And if you scroll down here, it's got, it explains some stuff here you can read on here. What I really like is this little interactive tool. And you can click like the sign, and it lets you move around and adjust your angle, and it shows you how things change, and you can move B around, and it changes the size, and it lets you change the angle. But what I really like here is it lets you practice finding sine, cosine, and tangent. It lets you practice all three at once. This is actually the assignment we're going to do tomorrow. But like the sine of theta, so sine of theta lets you find the ratio. So sine is opposite over hypotenuse. So my opposite number is 109. My hypotenuse is 293. And it gives you immediate feedback. Now, 0.372 is not the angle. 0.372 is the ratio of 109 and 293. But if I did the inverse sine of 0.372, it would give me the angle. So like if I went to my angle here and I did inverse sine, and I did it this way, and I've already forgot like what those numbers were. So 109 over 293. So 109 over 293. That gives me an angle of like 22 degrees. And if I did inverse sine of that ratio, which is 0.372, it gives you about 22 degrees. Okay, so all it's doing is giving you that fraction. So it's not actually giving you the angle. But the whole point of this is it's letting you practice the ratio, seeing can you identify the right sides for sine, cosine, tangent. And so if you click another, it changes the triangle, and it gives you cosine. So cosine is adjacent over hypotenuse. So if you find theta, where theta is marked, adjacent is going to be 266, and the hypotenuse is 281. And then it lets you check. Okay, so let's say, okay, so here's tangent. So let's do a wrong one and see what happens. So let's just say here, we type in 248. That's the hypotenuse, and the hypotenuse is not even used in tangent. And we do 82, okay? So we type that in, and nothing comes up. So immediately when you type in the right answer, it tells you it's correct. So nothing happens here, so you know that that's wrong. So then you got to try something different. So tangent is opposite, which is going to be 82, over adjacent, which is 234. So immediately, as soon as I type in that 234, as soon as I type in that correct answer, it says that you're right. Okay, so let's say you know by sine, let's say you type in the hypotenuse first. Let's say you like doing that first. So 184, and then your opposite is 118. You can do it that way as well. It doesn't matter which number you type in first. So if you just want some good practice, this is a good website to just practice getting to know and identifying your opposite, your adjacent, and your hypotenuse. So I really love this quick website here. This is just a great website for that. Okay, so let's go back and do our last problem. So a wheelchair ramp, we know we're dealing with our right triangle here. So I'm going to draw my right triangle. Build an angle of 10 degrees. The length of the ramp is 8 feet. So my ramp, here's my ramp, 8 feet. What's the height? We want to know the height. And remember, I like staying away from h's because I would confuse that with my hypotenuse. So I'm just going to use an x. So here we go. 10 degrees. X is opposite from 10. And then this is my hypotenuse. So which one of those uses a combination of opposite and hypotenuse? Well, that would be sine. So sine of 10 is x over 8. I'm going to move 8 up and over. So I'm going to do 8 times sine of 10. So 8 sine of 10, 1.39. So 1.39 would be the height. And that's it.